Welcome to the Chapter 5 lecture on elasticity and its application. We are going to start the quantitative portion of the course in Chapter 5. The math in this chapter is not complicated, but it is important that you use the correct formulas when doing the calculations. The title of the chapter is Elasticity. Very simply, elasticity is a way to measure responsiveness. The book definition of elasticity is the measure of responsiveness of quantity demanded or quantity supplied to one of its determinants. By calculating elasticity, we can look at changes in quantity demanded or quantity supplied quantitatively. Chapter 5 will cover 4 types of elasticity: price elasticity of demand, income elasticity, cross-price elasticity, and price elasticity of supply. Let's start with price elasticity of demand. You should remember the law of demand from Chapter 4. The law of demand expresses the inverse relationship between price and quantity demanded. Consumers respond to higher prices by decreasing quantity demanded or increasing quantity demanded with lower prices. The question that we want to answer is by how much more or less does quantity change by? Does a 5% change in price result in a 3% change in quantity demanded or a 13% change in quantity demanded? Price elasticity of demand measures how responsive consumers are to price changes. Elastic demand means that consumers are relatively responsive to price changes. Inelastic demand means that consumers are relatively unresponsive to price changes. ED is going to be the coefficient that we're going to solve for. ED is called the price elasticity coefficient and is the measure of the degree of responsiveness. ED is calculated by taking the percentage change in quantity demanded divided by the percentage change in price. It is common practice to drop the negative sign with price elasticity of demand, since we should already understand that there's an inverse relationship between price and quantity demanded. Let's go through a quick numeric example. Suppose that a 10% increase in price of ice cream causes the amount of ice cream demanded to fall by 20%. When I work on math problems, I like to write out the formula before I do anything. Price elasticity of demand equals the percentage change in quantity demanded divided by the percentage change in price. Now I'll put in the numbers. There's a 20% change in quantity demanded and a 10% change in price. Therefore, the price elasticity of demand coefficient is 2. Right now, the number 2 doesn't mean anything, but in a few moments, we'll go over the meaning of the coefficient. More often, you will have to use the midpoints formula to calculate price elasticity coefficient. The midpoints formula is essentially the same as the original formula. In most cases, you'll be given price and quantity data rather than the actual percentage change. The midpoints formula allows you to easily input price and quantity data to solve for the coefficient. The midpoints formula is Q2 minus Q1 divided by Q2 plus Q1 divided by 2. All of that divided by P2 minus P1 divided by P2 plus P1 divided by 2. Order of operations is crucial with this formula. If you type everything straight into your calculator, you will come up with the wrong answer. Let's go over a numeric example. Suppose you buy 120 ice cream cones a year when the price is $4 per cone. If the price increases to $6, you will only buy 80 cones a year. We can already see the law of demand in action. Higher prices translate to a smaller quantity demanded. Let's use the midpoints formula to measure the degree of responsiveness. Since we're dealing with data, we need to make sure that we label everything correctly. P1 is the first price, $4. P2 is the second price, $6. Q1 is the first quantity, 120. Q2 is the second quantity, 80. Plug this information into the formula. 80 minus 120 divided by 80 plus 120 divided by 2 divided by 6 minus 4 divided by 6 plus 4 divided by 2. Again, order of operations is crucial. Be sure to simplify your fractions before you divide. If you do your math correctly, you should get an answer of 1. What does a coefficient of 1 or 2 mean? Well, being able to interpret the coefficient is very important. If you do your math correctly, you ultimately want to know what the number you are solving for means. Elastic demand occurs when the coefficient ED is greater than 1. This means that the percentage change in price resulted in a greater percentage change in quantity demanded. An example would be a 5% change in price causes consumers to change quantity demanded by 15%. Consumers are very responsive to price changes. Inelastic demand will occur when the coefficient ED is less than 1. This means that the percentage change in price resulted in a smaller percentage change in quantity demanded. An example would be a 5% change in price caused consumers to change quantity demanded by 2%. Therefore, consumers are relatively unresponsive to price changes. Unit elastic demand occurs when the coefficient ED equals 1. A percentage change in price results in the same percentage change in quantity demanded. An example would be a 5% change in price causes consumers to change quantity demanded by 5%. There are two extreme cases that are mathematically possible. The first is perfectly inelastic demand, in which the coefficient will equal 0. The percentage change in price results in no change in quantity demanded. An example of this might be somebody who is diabetic and needs insulin. If the price increases, the person still needs the same quantity of insulin as before. Therefore, demand does not change. The other extreme case is perfectly elastic demand, in which the coefficient equals infinity. The percentage change in price results in an infinite change in quantity demanded. Very small changes in price lead to huge changes in quantity demanded. Elasticity is related to total revenue that a firm brings in. You might be thinking, why are we studying price elasticity of demand? Well, measuring how responsive consumers are to changes in price can be very valuable information for producers. As demand changes, so does total revenue. The formula for total revenue is price times quantity. TR equals P times Q. Firms want to know how total revenue is going to change when demand changes. Let's first look at elastic demand. Remember, elastic demand means consumers are relatively responsive to price changes. The percentage change in quantity demanded is greater than the percentage change in price. If price decreases, consumers are very responsive and increase quantity demanded, causing total revenue to increase. If prices increase, consumers are very responsive and decrease quantity demanded, causing total revenue to decrease. Let's look at elastic demand graphically. Let's look at elastic demand graphically. Remember, price is always on the vertical axis and quantity is always on the horizontal axis. All demand curves are downward sloping. At point A, price is $2 and quantity demanded is 10. Total revenue is the shaded area, which would be equal to $20. If price decreases, we end up at point B. At point B, the price is $1 and quantity demanded is 40. Total revenue is the shaded area, which would be equal to $40. We can see that total revenue increases when prices fall, or that total revenue decreases when prices rise. Next, let's look at inelastic demand. Remember, inelastic demand means that consumers are relatively unresponsive to prices. A percentage change in quantity demanded is less than the percentage change in price. If price decreases, consumers do not respond very much. Therefore, total revenue also decreases. If prices increase, consumers do not respond very much. Therefore, total revenue increases. Let's also look at inelastic demand graphically. Remember, price is on the vertical axis and quantity is always on the horizontal axis. All demand curves are downward sloping. At point C, the price is $4 and quantity demanded is 10. Total revenue is the shaded area, which would be equal to $40. If price decreases, we end up at point D. Price is $1 and quantity demanded is 20. Total revenue is the shaded area, which would be equal to $20. We can see total revenue decreases when prices fall, or that total revenue increases when prices rise. Lastly, let's look at unit elastic demand. The percentage change in price results in the same percentage change in quantity demanded. If price increases, total revenue stays the same. If price increases, total revenue stays the same. Let's also look at unit elastic demand graphically. Remember, price is on the vertical axis, quantity is always on the horizontal axis. The demand curves are always downward sloping. This demand curve has a bend to it, but it's still downward sloping, so it's still a demand curve. At point E, the price is $3 and quantity demanded is 10. If price decreases to point F, price is $1 and quantity demanded is 30. Total revenue is the shaded area, and in both cases, total revenue is $30. We can see here that total revenue stays the same when prices fall or when prices rise. Okay, it's actually not that easy. We can actually have elastic, unit elastic, and inelastic demand all on one demand curve. Elasticity can change along a linear demand curve. Linear means a curve without any bends. The reason why elasticity changes along a downward sloping demand curve is due to the fact that a 1 unit change with large numbers is a relatively small percentage change, while a 1 unit change with small numbers is a relatively large percentage change. Think about a $1 price change on an item that costs $1,000 compared to an item that costs $1. A $1 change on an item that costs $1,000 is a relatively small percentage change, but a $1 change on an item that costs $1 is a relatively large percentage change. Let's look at this graphically. The top diagram shows the demand curve. The bottom diagram shows total revenue, which is what we just discussed on the last few slides.